This is chapter 10.2. So we're going to be talking about combining resistors, resistors in series, resistors in parallel. All right, so let me draw a circuit with resistors that are in series. So this is the battery, and you have two resistors. Now let me just label the voltmeter across. This is R1 and this is R2. This is V2. So the voltmeter is across the resistor R1, that's V1, and V2, the voltmeter, is across the resistor R2. And you have the current I1 and I2. Now if you use Kirchhoff's first law, I1 is equal to I2. So Kirchhoff's first law, we can say that I1 is equal to I2. And if we use second law, we can say that V1 plus V2 is equal to the EMF. So this is the EMF. And let's just say that's V total. So V1 plus V2 is equal to VT. So if you remember, it's the sum of the potential differences in the circuit in one closed loop that is equal to the sum of the EMFs. Now, assuming that the EMF is just VT, where T means total. So V1 plus V2 equals VT. Now, what formula do we need to use now? So we need to use Ohm's law. Now, what's Ohm's law? V is equal to IR. So in this case, if we apply V for this component here, V1 is equal to I times R1. If we use V equals I for this one, V2 is equal to I times R2. What's V then? So V is equal to I times R total. So V total is equal to I times R total. All right, so what happens when we add them together? So in terms of I and R1, so we can say that using this equation here, that is equal to this. So IR1 plus IR2, that is equal to IRT. Now, because it's the same current in this circuit in one loop, divide everything by R, we end up with R1 plus R2 equals RT. So we can rewrite this. We can combine these resistors as just one single resistor, as though it is one single resistor. So we can rewrite this as R1 plus R2, and this would be VT. This is equal to I. Now, what happens when you have a parallel circuit with resistors? So let me draw a circuit in parallel of those resistors. So this is the EMF, the battery, and this is the resistor. So let's just say that's R1, and this resistor is R2, and you have V1 across here, and you have V2 across here. Let's draw the ammeter here. So you can have an ammeter here. All right, so this is the EMF, and let's just say that's the V total again, V total. All right, so this is I1. So this current here is I1, Now, because of Kirchhoff's first law, can you see that it splits? So this is the node. Can you see that this is going to be, so here's going to be I2. Let's just say that's I2 and that's I3. So can you see that I1, it splits into I2 and I3. So that is equal to I2 plus I3. Now, the voltage across there is the same as the voltage across there because there's only one component. If you had two, then V1 plus V3 would equal to VT. But here, let's just say there's one resistor there. So the voltage across this is equal to the voltage across here using Kirchhoff's second law. So this is Kirchhoff's first law. And Kirchhoff's second law, that would be V1 is equal to Vt. Likewise, this is Kirchhoff's second law, and Vt is equal to V2 is equal to Vt. This is Kirchhoff's second law. Now, again, we need to use Ohm's law, don't we? So Ohm's law. So Ohm's law, V equals IR. So in this case, V1 is equal to I2 times I2 times R1. You know what, let's change these numbers because that's not, let's change this to just I, and this is I1. This is I1. This is just I2. So this original current is split into two currents, I1 and I2. So I1, this current is flowing through this part of the wire, and it's going through the resistor, and V1 is the voltage across R1. So just make it more simple. So here is therefore I1 then. And V2 is equal to I2 R2. Okay, so what do we do now? V1, do we add them? Do we add them together? All right, yes, we need to rearrange for I1. Because let's rearrange for I1. So what's I1 equal to? So I1 is equal to V1 over R1. V1 over R1. And we know that I2 is equal to V2 over R2. And we know, and therefore I is equal to, okay, using this, because Vt is equal to I times RT. So rearrange for I is equal to Vt over RT. So I is equal to I1 plus I2. So this plus this is equal to this. So V1 over R1 plus V2 over R2 is equal to Vt over RT. However, V1 is equal to Vt, V2 is equal to Vt. So these voltages are the same. So you have the same V's, same V. So you can cancel them. That will just go, that will go, that will go. So therefore 1 over R1 plus 1 over R2 is equal to 1 over RT. All right, so let's do an example. So you got a 5 ohm resistor in series with a parallel combination of 6 ohms and 2 ohms. What is the equivalent resistance? So first, because we know that when it's in series, you just add them together. But let's focus on the parallel one first. So what's the equation for parallel? Resistors in parallel. So parallel, it is 1 over R1 plus 1 over R2 is equal to 1 over RT. So R1 is this one, R2 is this one. So 1 over 6 plus 1 over 2 equals 1 over RT. That is equal to 8/12. 8/12. So that is equal to, divide top and bottom by 4, you get 2/3. Yep. So therefore RT, you flip it upside down, so it's 3 over 2 ohms. So the equivalent resistance for this combination is 3 over 2. So 5 ohms, and that's 1.5. And because it's in series, you just add them together. So series, you just add them together. And so what's the total? 6.5. So your answer is 6.5 for this one over there.